So the recording has been started, and Laura, Roderick, please go ahead.
Okay, thanks Cornelis, and thanks everyone. So we go today with this SAREF tutorial, and we do it together. So I start for some introduction, and then Roderick will take over on some more specific parts of the tutorial. Let's see, I can change the slides. Yes. So we give first an introduction into SAREF, what it is and in general. Then a methodology. So when you use SAREF and for what, which I think it could be very much in context what we are doing also in HEDGE. Then we go with a SAREF overview. What is in there, and we are talking about the main module, the module called the SAREF core. And then we zoom into specific classes of SAREF of interest for us. And then for each of them, we present, well, a graph to show you that part and some examples. And we will have an interactive moment. That's why I was also checking whether there is presence from people. So expect every time we explain a class, a moment of 2 minutes where we ask you to write down something in the chat concerning your pilot. It's very, very simple questions, but it's useful first to make it more interactive instead of somebody just talking, and also to start collecting information, also for you to get to know SAREF a little bit more in an active role. And then we also, of course, leave some references and further reading for going further with the learning and getting acquainted with the SAREF. Hopefully, what you will learn after viewing and following this tutorial is what is SAREF, how to use it, so and when, what's useful for, when to find SAREF, especially SAREF core that we are presenting here today and its documentation, what are the main concepts that SAREF core module specifies, and how to relate these core elements from SAREF to your pilot. Also, since we will present a graph, we will also show you what is a knowledge graph. So in principle, you also learn how to interpret a simple, what's called a knowledge graph, which is an ontology plus data that it's in it, which are made of nodes and edges that connect those. And I don't know if we will have time, but there is also a bonus. So in case we manage to arrive to the point that we also show the so-called triples, which are triples made of a subject, predicate, and object, which corresponds to nodes and edges of this graph, so that you have even more insights on this. It is a little bit more technical, so I don't know if we will get to that and everybody's interested, but that's at least what you will learn, even when you look at the slides later on your own after this moment today together. Was there
1
a
second,
question?
there's a question from Leo. I think you were wanting to say something about the slides.
Yeah, see, I just noticed a delay between what Laura was saying and the slide presented. So maybe, yeah, from my side,
that's
I was
true,
seeing
because
first.
I think Laura, you were manually, but that is only like your own internal view. So I need to go to the next slide for all for the viewers. So
okay.
I will follow along with you, and indeed.
Shall I tell you every time to move the slides?
Yeah,
then otherwise I
if
click.
it's not clear
You
from
know
the
the
story.
presentation. Yeah.
I think
Okay.
Laura can take the control with the icon on the top left. You have an icon named control, or take the control, and then you will be able to switch automatically the slide.
It should be there, but I don't see it because I'm originally shared the presentation.
Yeah.
It's at the left of all the controls. So where the chat and the pop-out is, the most left icon says take control.
Yeah, I see it on the left. No, I was looking on the right, actually. Yes. So if now I do this.
Yes, now we all see when you go to the next slide.
Okay, so very good.
Great. Thank you.
Okay.
Sorry for the interruption.
So now you should be seeing slide number 3, which is what you will learn, correct? Okay.
Yeah.
So now let's go to see what is SAREF. So we give an introduction. And it's an acronym for Smart Application Reference Ontology. But although it is ontology, singular, it's actually a framework of ontologies, because today we see SAREF core, but there are more ontologies in different domains. It's a series of modules of ontologies, which is done to facilitate interoperability between IoT, devices, systems, applications, different vendors, different everything, basically. And it is important to say that it's an open standard. So it's a standard, but it's also open because it's maintained and evolved by HEDGE. And whatever HEDGE, which is the European Telecommunication Standardization Institute, does is open to the public in the moment it is published. And if somebody is a member, also the various intermediate drafts should also be available for them. And it is, there is a portal, which is sarefetsi.org, which contains all the extensions, information of SAREF, documentation, and also some HTML documentation where you can navigate also the ontologies without necessarily opening the PDF documents. Now, this is the modular framework. So at the moment, so we started with actually one ontology a long time ago in 2014. And then we realized that there was the potential for this to actually work in several domains. So we identified a core component, which is horizontal to all IoT applications. So sensors are sensors everywhere, regardless if they are applied in agriculture, in energy, or in buildings. But then we started creating also some domain-specific extensions. So originally the first one were SAREF for energy, SAREF for building. But then with time, this was extended until at the moment we have 12 domain-specific extensions ranging for energy, and then also smart grids, but also lifts, water, wearables, e-health, aging well, and so forth, automotive, and so forth. Together with that, there are a couple, some patterns of the parts that you see in the lower part of the screen, which are patterns extrapolated from various general patterns that you can use across various extensions. Then we go to the next slide, which is this one, why SAREF? Interoperability we already mentioned, because then we can make communicating a common understanding among people and systems and communities and standards that have been developed at different times by different communities, so with different semantics and data models, underlying data models. It's important for standardization because standards are important, and being, since its very initial development in 2014, supported by one of the ESO, European Standard Organizations, which is HEDGE, it makes it obviously very strong because it's standardized, it's evolved by HEDGE, and there is a very well established governance then between HEDGE, the community, and the experts, and the industry, the stakeholders. Then the third is industry adoption, because in all these years, basically a decade of work as a standard, it has been widely adopted by various industry sectors, which is good. Actually, it started also with some industry sectors because there were companies that started together with us, like Bosch, Siemens, and Whirlpool. So manufacturers of smart appliances started since the very beginning, were very pioneering and visionary in the development of SAREF. And then there are many more now, fortunately. And it's important from a policy perspective because SAREF can be used and is used also for some regulation in Europe. Actually, like the European Code of Conduct for Energy Smart Appliances that was launched last April, in April 2014, by the European Commission and the JRC. And this is one example, but it can be put in any regulation because it's a standard. So that's where it gets very, very handy also. Then there are some technological principles, fundamental principles that have always been used in SAREF as ontology and framework of ontologies during its development in this over 10 years of evolution and development. So first, reuse and alignment, because we talk about SAREF, but SAREF reuses also other ontologies and concepts that are available elsewhere, because we are not reinventing the wheel. And we align with some other ontologies in the domain that exist, like an ontology that you might know is SOSA, the Sensor Network Ontology, SSN SOSA, which is another famous one that comes from W3C. But there are others in general. So reuse, it is important. In the same way, it is important for others to reuse SAREF if it is already there, because then again we are not reinventing the wheel in any place. Modularity, we have seen that. So there are modules, and in general, even within the modules, it is possible to separate and recombine parts of the ontology of the framework based on specific needs. So not everybody needs the whole SAREF, the whole SAREF extensions. There are few extensions that you might need, a part of this, a part of that. So it's a kind of building blocks that somebody can use. Although it's also a complex framework because there are a lot of things. So if you know where to go and what to combine, it's very handy, but of course, it could be also a little bit overwhelming at the beginning. That's why we have tutorials like this one to explain. It is extensible, so we can, it has always been designed to expand and grow to, for example, accommodate new requirements if a new domain becomes then important, or to make changes, because that can also happen. Those domains are dynamic, so it's not that it's written on stones at some point. What is it there? Core important things are stable, but there are certain things that dynamically can change or become new. So, like for example, in HEDGE-IoT, we will start using SAREF, but if we figure out that there is something missing, it means that there are maybe new requirements that have not been taken into account, and we can then present a new extension or part extended with a few concepts. And then the fourth is so-called type token distinction. So it allows to make a distinction between type of things, of objects, which are classes, but also specific instances. So the data that it's in there. So the class of a person as the type of class, person, people, and so forth, but individual instances. So Laura or Cornelis or Roderick are instances, specific instances of the class person. But then also we can accommodate generic catalogs, but also specific entities. So this means that we have classes, we have a way in SAREF to accommodate things like washing machine series from a certain manufacturer. And this is a kind of something that can go in the catalog, because it is something that can be reused. There are several instances of this existing. But my washing machine of that specific series and model and of that manufacturer, it is my washing machine. So this is an instance that is very specific to me. Or if we do certain type of things within the Dutch pilot or something, this is specific for the Dutch pilot. Now, this is an important one, and I hope you can see it, but in case you cannot see it, you will find this. There is a link in the slide, and this is coming from the ETSI European norm on SAREF, the 303760, which provides guidelines to develop, apply, and evolve smart application ontologies for IoT semantic interoperability. So this was published last year. So it's a very new and recent, but it's very nice because it provides the methodology on how to become somehow SAREF compliant. And to be honest, it's not only about SAREF, because in reality it is applicable to ontologies in general. Let me quickly go through this. So when you get this this standard, this document, then the starting point is that a company, a partner in HEDGE-IoT, whoever, wants to apply SAREF in their product or solution. So you want to use SAREF, basically that's the thing. So then there are several steps described in this standard. So first is do an assessment about your own expertise on ontologies, okay? Because there can be people that are much more familiar and acquainted with ontologies and others that are not. It's the first time they're hearing the term ontology. So in that case, this document guides you into which parts you should look at. The second step is define your use cases, because it's an important best practice, as we know, in HEDGE-IoT. So in Edge, we have already defined all our use cases. So that's a good part, because in principle, it's already the step 2, it has been already done. Step 3 is, so if these are the use cases, what are, from these use cases, the core elements of this that corresponds to SAREF concept? So it's a high-level mapping, not yet something really specific, but a little bit high level of trying to map and understand, which is also getting acquainted with SAREF, which is what we are doing, for example, today with this tutorial and the other tutorials, because you need to get acquainted also with this framework. So what you can find in SAREF Core, what you can find in SAREF for Energy. So first is your use case. What should use SAREF and or SAREF for Energy, and a little part of SAREF for Building or SAREF for Grid, or some other concept. So that's the initial phase of step 3. And actually, we are doing these activities now in task 4.3, where we are currently. Then in step 4, it's also okay, it's the part 3 and 4, it's what we are doing basically to map these things there. So when you know also in more details what type of data you need from your use cases, which actually in our SACs we know, because we have developed detailed specifications in the documents in our deliverable HEDGE-IoT for that. We can, let's go to the main flow, right? So the one that it's going down, because it's also the most important. Then you can translate your data into SAREF compliant data. So it's a phase of a mapping, and that's also something that we will support in task 4.3 for all the pilots and the partners that are interested in doing that. And okay, according then to this flow, still going to step 4 down there, it's if you want to be fully compliant, you also have to show that that you have done that. There is a kind of a checklist, an auto certification that you can do in the last page of this document. You can find it where you show that you have done all these steps, and therefore you kind of auto certify that you will have your data SAREF compliant. On the right side, you see some optional parts, which are that if you don't find the concept that you need in SAREF, then you can create some extensions. So if in our use case is not everything is covered, but we need something, then we can say, okay, then we create a few new concepts and we include it in SAREF. Another optional thing is the step 7, which is test your SAREF compliant data, because you can map data into SAREF, into the model, but how do you know actually if this is really compliant, and if two machines, two applications, two end-to-end applications can actually exchange this data? So this is very highly recommended, and in the previous project Interconnect, we really did it in all the pilots. I don't know in which of the pilots we will be able to do this time, which is probably in the Netherlands and in Portugal. But if others are interested, of course, we can investigate that. But this is really nice to show the full interoperability until the testing phase. And the step 9 is that eventually, if there are new concepts that are found not covered by SAREF and an extension is suggested, then this you can keep it in your own project. So we could say, we did this, we keep it only in Edge, we used it it's for us, we know it, but we could also submit it to HEDGE, to the standardizations, to make it become officially an extension of SAREF that everybody then can use. So this will be really labeled as SAREF or SAREF for whatever those extensions. Now, I wanted to, it's probably a little bit long, this explanation, but I wanted to give you the context to why are we doing this and what to expect later. Do you have any questions on this? I will stop a moment because I think it's important if there are questions on this.
Maybe one question from
Yes.
Trilog side. Do you have an estimation of the workload to push a new concept to for example, to HEDGE? For example, in the Dutch pilot, you identify a new function or a new need, you create the model. Is it feasible in the context of HEDGE-IoT, or is it something to initiate in HEDGE-IoT and to continue further?
In principle, the better is embedded in SAREF, the clearer is the reason for that, and the more active you are in doing the contribution, then it is doable. So to give you an example, in Interconnect, the process of creating a new version of SAREF for energy, the standardization process itself, so from early draft, stable draft, final draft, and publication was 8 months. So we really managed to do it before the end of the project. However, creating this extension took 2 years within the project because we had to create and because we created very big contributions, very major contributions. If the contributions are smaller, they can be done and initiated even before. So it is possible, and it depends on how active also then you are in the standardization, but it is possible.
Okay, thank you.
Okay, then I think we go to the next slide, which finally, I believe, tells you what is in SAREF, since we have been talking a lot about that. So I'll give you this overview and to stress is that this is SAREF Core version 4. So the document will be version 4.1.1. You can find it at that link. However, we really published this now in March. So in this, actually it was published 2 days ago. So when you go now to the website at saref.etsy.org, you still find the HTML documentation when you click on the version 3.2.1, but this will be updated. It's a matter of coming week or something until the end of March. So, so just to say to you that if you want to navigate that, you can do that, but that's still the version 3.2.1. And version 4, compared to that, it's much more clean, consolidated. So it's obviously a good major release, the version 4, and so yeah, just a little bit of patience, but then will be updated there soon. Let's start with these. These are the main concepts. At the center, you see the device, because we said it's for IoT, and then devices are very important there. So devices that could be sensors or actuators, appliances, as we mentioned, washing machines and so forth, heat pumps, meters, energy meters, smart meters, and so forth. Those devices, I go quickly to the left part down, and then I go then on the right part. But in general, devices are developed for with a function in mind. So if you have a washing machine, you will have will do some start and stop function. If you have lights, you will have on and off functions, or up and down if it's about blinds and so forth. Then those functions, which are the goal for which those appliances are exist, can be put in a network. Usually they are in a network nowadays. In IoT, everything it is, and then they become a service. So then you have a service that is offered to switch on a light or to start and stop the machine from your mobile phone, for example, instead of pushing a button to start the washing machine. And then there are also commands, which are the switch on and off of the light, or start and stop of the machine when you start the start command and so forth, and operations that are more defining what happens in these services, what are the operations and input and outputs, more for representing it into a machine-to-machine, let's say, way operation. Now, devices have consumed, basically, they are related to a commodity task. So you have your washing machine, then it's because it's cleaning, or you have a TV system, it's for entertainment, or you have something that could be done for comfort. They relate to a commodity because then washing machine, it's or solar panels will be producing some energy, while a washing machine will be consuming and so forth. And then on the right side, devices, you see something that is called procedure execution. Let's say that devices, for example, a sensor makes an observation. An observation is an observation, a measurement, so measuring a temperature. An actuator is something that made an execution. So it's when you want to switch on something, you do an actuation, or if there are doors that open automatically, there is an actuator that is opening those doors and so forth. And those are because devices control properties like temperature, but could be many more. And an important concept is the one of feature of interest, which provides the context where all this happens. So you can have a device which is measuring or sensing something, observing something, and the feature of interest give you the context of this. So we will see later also with Roderick, but you can have a sensor in a room, and then the room is the feature of interest, is the context where this temperature is actually measured, because this device that is measuring the thing. Or a temperature could be also the temperature of a person. So the fact that it's a person or a room makes you understand what's the context. And those are the feature of interest that you see on the right. And also, those have property values, so this feature of interest. So the body temperature of a person or the room temperature of somebody, they have a property value, which could be then a temperature of a room, it's probably 20 to 22 degrees, but the temperature of this property for the body temperature is quite higher, than 36 degrees Celsius or something. So based on that, this context, something that it's a temperature by itself changes, because you can understand who is, what's the context. And very important is that unit of measure should be coupled with values, because as I just mentioned, if I say a temperature 22 as a number, you might understand that it's in degrees Celsius, but if we don't explain it, machines will never know that that's the case. Now, I think it's time that I leave then the presentation for Roderick, which will focus on the part of this tutorial, which is the one on the right. Not because the other one is not important, but after years and years of experience, we see that the right one is the one where projects like HEDGE-IoT and Nurse Interconnect before tend to focus on. So, Roderick, do you want to take over?
I'll try. Can I use the take control button?
So I will stop sharing. Yeah, you did it. Perfect.
Thanks. Then we first go to the device class. As I already said, that's the main class from which all the other follow. There's a few more classes here on this slide that weren't visible on the overview slide. That's because the overview didn't have everything, but this was more a selection of the most important ones and the ones that you will most likely use. And these come in effect when you select it, whether you use a device or a feature of interest or something. So for the device class, there's two different kinds of arrows. There's the black arrows, which are relations going from the device to a different class, and there's the arrows with the white hat. Those are define a type relation. So a device can also be a system, and a device can be a feature of interest, because when you're observing the battery capacity of a device, then the device is its own feature of interest because it's its own battery load that it still holds. Same with the white arrow at the bottom. There's 4 types of devices. There's appliances, sensors, actuators, and meters. And then on the left, that's a new one. A device and a device kind is a relation that comes back a few times in SAREF, where a kind is a general class for a specific device. So for the class SAREF device could be a specific instance of a sensor, but then its corresponding device kind is that brand or that model of sensor. And then we have the task, which Laura already explained, and the commodity. And I'll go to the next one. These are a bit more specific definitions of all the classes, which is also useful for when we share the slides later on, that it's not just images, but also some information. And then we have an example of a kind of device where it consumes a commodity, which is electricity. It accomplishes a task, which is metering, because it's a smart meter. It has a label, which is its type, its name. It has a comment, which is a way to describe it as which the modeler can use. It has a manufacturer and a model. And then it has device kind, which is the type of smart meter that this is, which itself, again, has a label and a comment. And then we get to the interactive moment. I would like to ask everyone to think about your own pilot and try to put in the chat what kind of devices you have available in your pilot and that you would have to model using SAREF if you would choose to use SAREF. So which type of devices and which type of systems. For the feature of interest. So again, as Laura already described, the feature of interest is the context of a specific observation or something that the device controls. So not to be confused with a machine learning feature or anything like that. So if we get to this could be a room or a building, but it could also be a device or the specific device, or anything that can be observed or controlled. Same as with device kind, where you could have specific an instance of a device and a type of device. With the feature of interest, you can have its corresponding feature kind. So if we go to example, we can have a sensor that makes observations related to a room, and that room is in the feature of interest, and it has a feature kind that is office room, because this room is a kind of office room. And again, in the Dutch pilot, we have buildings and solar panels and parking spots as kinds of feature of interest. And again, the question to you, if you can think of features of interest related to your own pilots. So if we have the feature of interest as the context, for example, a room, then the property is the property of this feature of interest that we make an observation about or that we control. So that can be the temperature or CO2 values, humidity, but it can also be the square footage of a room, because it does not have to be a property that's actively being manipulated or observed. It can also be a constant. That's where the class property value comes in. Those are the actual values of the property of the feature of interest. So they really combine to represent the information. So you know what the feature of interest shows, what the context is. The SAREF property shows what part of that context is discussed, and the property value shows what's actually the value of that part. Here we don't have the a kind of something, but of interest, which is the inverse relation, where the kind was the type of device or the type of room we were talking about, and of interest is the specific instance of a property. So for this example, that means that the property, so we always go back to the room, which has a property, its dimensions, and then the property of interest is specifically for that room, the dimension. These have a property value, which is an instance that has a value of 16 and a unit of measure of square meter, because it works well for dimensions. And brings us already back to the next interactive moment.
Yeah. So given properties, again, the devices, feature of interest that you have, what are typical properties, which can be physical properties or whatever? As examples, we give you the one in the Netherlands: energy, temperature, gas.
Procedure execution, which can be multiple things, but for now we specify the types of procedure execution, the observations and actuations, which can only be made by a sensor if it's an observation, and an actuator if it's an actuation. So first, the observations, where an observation is a, for example, temperature measurement or CO2 measurement that's made by a specific sensor, and that has a result in the shape of its property value related to the property and feature of interest. And as an example, that can be a sensor making an observation, again, about the room, which is taken at a specific time and has as a result a value 12 with a degree Celsius, because it's a temperature measurement, which you see in the property. And those are observations. And these are them for the Dutch pilot, and feel free to share your own. So where an observation was a device making a measurement about something, observing something, now an actuation is a task being performed, something being the command being sent to a device. So, and this is the record of that that act, that performance being done by the device. So it controls a property, it acts upon a property, and is made by a device. For example, a lamp that makes an execution at a specific time. It acts upon the light of a specific room, and it accomplishes the task of lighting. And then there's a few examples from our side. And again, please feel free to share your own.
I think we still have some slides to present, but we are almost at the end, that the main important things have been presented. So we could try to rush through all the others, or we could also next time take a little bit of time to finalize this. I don't know. And in any case, everything is in the slides. I don't know, Cornelis, what do you think?
Yes, thanks a lot for the presentation, first of all, Laura and Roderick. I think it's good to mention that, can you go to the next or next slide? Because when you look up these slides, when they're on the PowerPoint, also in the next slide, there are links to where you can find the additional technical specification and documentation of SAREF, which is published on the ETSI website, both in HTML documentation as well as in PDF standard where all has been specified. So we expect that a lot of questions around some of the technical details can be found there. But it also highlights more of the scope of why we use this, as well as the fundamental principles that Laura mentioned at the start